Welcome everyone to the talk which I called Hunting with Stream Gatherers. Briefly about myself, I'm Piotr Przybył. I work and live in Poland. These are my social media whereabouts. I work for a company called Elastic. That's why you can find some stickers here. I mean, you can come and grab as many as you wish. I'm also Java champion, test containers community champion, and sometimes from time to time I wrote to my personal blog page called softwaregarden.dev. Question is, who are you? Who's Java developer? Okay. Who's not a Java developer? Okay, just a few people. Okay, but still, I mean, that's important for me because then I know how to adjust the talk. Okay, a little warning, caveat auditoris. So let the audience beware. I do my best effort to present the topic accurately. Sometimes it's just my brain is gets into some twisted ways, and for example, replaces one word with another, right? Or I might be mistaken, as every talking head on the internet. So please verify on your own. It's a human thing to make mistakes. So normally I don't do agenda because I think talking about what you're gonna be talking about is kind of silly. So instead of talking about what you're gonna be talking, just start talking. But in this very case, it might be actually useful. Okay, so the little agenda is this. I start with prologue, then we'll cover three parts: the why, the what, and the how, and we'll have an epilogue for this. So the little prologue. Do you know what happened 4,026 days ago? Java 8, exactly. Java 8 was released. Yes, if I'm not mistaken, right? So that was 11 years, 8 days, and we had also 3 lap days in between. So let's get back to voting. Who's still writing code for Java 8? Okay, sorry. 11. 17. 21. 24. Okay, there's one person that okay. As you might remember, Java 24 has been released 1 week exactly, right? And you might be yeah, it's not LTS, it will take some time, and so on and so on. So I'd like to show you something. Just let me go and switch the keyboard back. So this is if you want to pull Docker images released by Elastic, you just go to the Docker Elastic CO, and we are about to release a new version of Elasticsearch. So that's what you can see, this 9.0 release candidate 1, which has been released 2 days after Java 24, correct? So then if I go to Docker, right, you can see that there's I have this image downloaded and running locally. I'll be using it for one of the demos, right? And as you may see, it's already running using Java 24, right? It says it in here, right? Or in here, Java 20, OpenJDK 24. And you might be saying, yeah, but it's easy for them because in search stuff, right? It was well prepared because it's this preview features and incubation, so we can try your stuff in advance. So then only 2 days after it's released, you're ready to use it. And it might be actually not that easy because there was this I wasn't prepared for this, but let's improvise. 486, if I'm not mistaken, permanently disable the security manager. Do you know what 2 pieces of technology were using security managers for real in Java? Apache Tomcat and Elasticsearch. So this is not a trivial upgrade, right? Yet the engineering team did magnificent thing, as you can see. So the next major version will be running using the latest Java. Basically, this is the principle. When there is a new Elasticsearch released, it's running using the latest Java that was available at that time, right? So the previous one were running using Java 23 and so on. Why is it important? Well, there are many reasons, and it's for example, bugs, it's performance, right? You get better garbage collector. It's also we use it for ESQL, so we get better support from the hardware with each ongoing Java version, and so on and so on. So as you can see, it's perfectly doable to upgrade it like in production 2 days after it's released, right? The world continues to shine. You not stick to Java 8 or something like this. And of course, there are more reasons to upgrade to Java 24. And one of them are stream gatherers, right? But before we talk about Java 24, let's go back to Java 8. And one of the big additions in Java 8 was lambdas, right? Or lambda calculus. And this was the cornerstone for streams, right? Can you possibly imagine using streams or stream API without lambdas? So again, you have to create these anonymous classes in place for every filter and map. And yeah, exactly, you're laughing. That would be a nightmare. That's why lambdas are like very, very important, right? And streams wouldn't be possible actually, or wouldn't be much usable without lambdas, right? So what is a stream, especially for those of you who are not familiar with Java? Basically, a stream is like a declarative way to process data. Okay, so you have some data, you want to declare like some operations, what happens on this data, and then you have a terminal operation, right? So we have a source, usually it's a collection, like a list or set, but it also can be a splitter later, basically something you can just iterate on, right? There you have any number of intermediate operations, like I said, filter, map, and so on. And then you have one terminal operation. And how they work, they are not push-based like these reactive streams, when you have to react to the data that's pushed to your system, hence the name, but they are pull-based. So when you create the stream, until you call this terminal operation, nothing happens. Right? And then only those things that are necessary are happening, not a single operation more, right? And these are the intermediate operations, at least most of them that were published with Java 8. So yeah, the ones we use frequently, like filter, map. When we go to the primitive types, we can go distinct, which is using the equals method. We have the skip, limit, and so on. Who's using peek? Keep your hands up. Who's using peek not for debug but from production issues? Please stop, okay? But there's not a single hand. So people are using a peek to debug this. I think Marit and I are about to give a talk to showing you how to learn modern Java and debug stuff without using peek in streams, right? But that's like some other conferences. So please follow us in London and so on. There are also some terminal operations, right? You can have this for each, reduce, collect. Actually, we could like have only one, right? Reduce. And this would be the mother of them all. So we could implement everything else using just reduce, right? Using this find first, find any, and so on. And there were more intermediate operations. Like in Java 9, we've seen take while and drop while. And Java 16, we've seen this map multi with primitive types. And there were also some terminal operations. Actually, there was one, to be precise, which is to list. That would create, if I'm not mistaken, unmodifiable list since Java 16. Right, we could do that previously, and I guess I have like even highlighted that in the IDE. But there were actually more terminal or more ways to terminate your stream. It's just they happened in other places. And in Java 9, we had two more collectors, filtering and flat mapping. In Java 12, we had very nice teeing. So teeing is like, let's say you have an idea that you reuse this sort of like reuse this stream or use this stream just to collect the elements in a different way. Let's say you have stream of integers, right, or numbers, and you want to create or get a sum and an average, for example, right? So instead of like recreating the stream, because fun fact, stream can be used only once, the Java stream, right? You can have just two collectors. You can tee them together, like the tee command in Linux, right, in shell, and then you'll get the elements pumped to both of them, right? This is a very useful thing. But what also happened in ecosystem is, for example, the thing that Grzegorz Piwowarek started, parallel collectors. Basically, so we could run the collectors using your own thread pool, right, and make them run in parallel. And of course, don't lie to me. If you are working in any serious project, right, especially in a corporate environment, you have this utils class, probably in the utils package, and you have some like defined collectors in there, because you could also like sort of like create your own library, right? So and now let's go. So that was the prologue. What happened to Java? Now let's go to the why part. Okay. So, or better said, the problems. Why are we even facing the change as stream gatherers? Okay. So for this, I'm going to do a little demo, or I hope this talk to be like a demo driven. What you see here is like a count out, right? So when, for example, where children are going to play hide and seek, they need to like select the one that's going to seek as the first one, right? So it's like a ini, mini, mini, mo in English. In Poland, we can have something like this, ene, due, rike, fake, and so on. Basically, what it gives me when I split it by space, I get a stream of strings, which is a stream of words, right? So this is my stream. And now, the task or the business need, let's say, is this. How do we get only one word by length? What I mean is this. I need to get through this whole stream and find like a representative word in this for each length that exists. For example, that for length 1, I will get E or I, right? That I will get nothing for 2 because there are no 2-character words in here. For 3, I can get ene or due, or I can get eus, right? One of them. And that's my business need, right? So now the question is, how will you solve this using streams? I should have a demo for this. Let's see if I have a demo. Yeah, so this is this stream, right? So I can go with collect, and I even tossed some comments for us, so it's easier to understand. Right, so I can go and I have this stream. I can go say collecting and then. So what I do, I have these collectors. I will be mapping them by length, right? And if I have like a clash, an existing word, and a new one coming, I prefer to keep the existing one, right? By the way, this is how we can now use in modern Java the underscore, right? It's something to ignore. That's why it was deprecated or banned in Java 9, and now we can use it again. So. And then at the very end, I wrap it into a hash, set the values. So let's just run it, right? So make sure I don't make things up. And yeah, see, this is the result. So in random order, I get Torba, Rike, Mateus, and so on and so on. So this is how we can do this, okay, in code. Question is, if we do it like this, all right, is it obvious to you when you look at this code what it does? Exactly. That's why some companies are benefiting from these AI agents to explain what the code is actually doing. All right. What happens if you need to reuse this code? Of course, it's possible, right? So we can create this unique length collector, right? And maybe this one is actually easier to comprehend or to understand. Let me go here just real quick. So I have this unique length collector, and this is my supplier. This is going to be my accumulator. So if the word is absent, I mean, if the length of this word is absent, I'm going to put the word, right? If I have just if I'm running this in parallel stream, I will merge the maps. And again, still, if you're into declarative or functional programming, the intent of this code might be obvious to you. But if you're not, right, you come from different domain, different use cases, this is not like what you get in 2 seconds, right? This code, when run, should be doing the same. It's Control R, isn't it? Yes. See, so apart from the order, because it's a set, we got the same results, right? However, what will happen if it's like a business as usual, and like we're in the middle of the sprint, right? And there's a new requirement, and it says, and we need to lowercase them all. Okay, so the words we get as a result need to be all lowercased. We might get something like this. Okay, so I have this collector, and then, as you can see, I'm using or abusing again this collecting, and I'm creating yet another stream to handle the task. Then I map them to uppercase, and I am collecting them to set, right? And functionally, this code works. It delivers what was requested. Would you feel dirty after writing this code? Exactly. right? It's very nice because it's like a declarative and functional style, but on the other hand, it's like a meh, right? And of course, it's not perfect because we create another stream, and some say, okay, but you could then go and map all the other elements right just at the beginning. Yes, but then I need to map them all, which means wasted CPU cycles because I'm not going to use these words later on anyway. And maybe we could decorate these elements because, like, wrap them, for example, in a record if you like from Java 17 onwards. Because how stream distinct works is just it takes or tries to see if the elements are already there using the equals method, right? So we would need to wrap it, for example, in a bean or in a record, override the equals method. So any two strings of the length 3 would give you equals 3. True, right, and so on. Another, like, a lot of ceremony to do this. By the way, I'm not sure if you've seen the bug. We were requested to make the words all lowercase, right? But what we did instead, or what I did instead, was uppercasing them, right? So as you can see, it's even that dangerous. And of course, we can have another hacky and pro and fancy solutions because we want to use streams no matter what, right? And the lesson from this is obvious. You can't efficiently use streams for this. The code becomes obscure. So what we all do, the for loop, right? Or the while loop. Let's be honest, right? Or what we could do is like to annoy the OpenJDK maintainers, and we can go and create like a ticket, please add stream distinct by method. So then instead of like creating these wrappers or anything like this, I could basically provide a lambda here, right? Taking two elements, and that will yield true or false, right? And telling that these elements are kind of like distinct by this comparison, okay? And they could have added distinct by, okay? But then what would happen is just there are more and more tickets like this, okay? There are more people requesting such changes. And of course, they have valid and legit business reasons for this. Only they constitute a tiny fraction of Java user space in general, right? And then you end up with two dozen extra methods just to satisfy the needs of, I don't know, maybe 2% of people. And you have like a long list to scroll in your IDE and so on. So as you can see, maybe they shouldn't have added distinct by, and that's why they didn't do this, by the way, I guess. So the thing is, if we only could use something else, right? Something else, like something like collectors only happening in the middle of the stream, right? Because you can write your own collectors, but you cannot write your own stuff happening for intermediate operation in the stream processing in Java. And here we go to the what, okay? Because apparently gatherers are the thing for this intermediate operation. So are you familiar with the concept of a plugin? Yes, it's a design pattern and everything. So from high view perspective, it's nothing more about like writing plugins for intermediate operations in Java streams, okay? So this was preview feature for 2 Java releases, and now it's a standard feature in Java 24. And as usual, I recommend you to go and RTFM, right? And don't hallucinate, please. And here comes the tricky part. Actually, I even had this conversation with Victor Klang, who is the caretaker of this feature, right? Why is it called gatherers? Because when I asked the AI, what are stream gatherers in Java, it gave me such an answer, key collectors, and it's not exactly what I was hoping for, right? Fun fact, this ended up as a whole new talk of mine called to rag or not to rag, when I explained how to tweak AI not to hallucinate like this, but that's another talk, okay? So as you can see, semantically, to collect and to gather are quite close with each other. That's why I instantly saw in my twisted brain that this is kind of like a, hunter-gatherer culture before we, the human species, became the farmers, right? Anyway, so let's delve into this concept, right? Certainly. So TL didn't read. It's like this. You have a stream of elements, right, from collection, and you can call gather operation any number of times, right? And then you call terminal operation, and that's it. Okay, that's the whole thing. Or if you're more into like a Scala or Haskell vibe, you go for and then. That's literally the same thing. What these gatherers can, they can transform elements in any sort of like quantity. So they can transform them one to one. They can take one element and return any other number of elements, from 0 to like virtually like infinite. They can take any number of elements and yield just one, or basically, as you could like guess by this, they can take any number and produce any number, right? Just to satisfy your needs. They can track processed elements, so they have their internal state. And if you like provide an object, of course, you can like even reuse it between streams. I'm not sure it's wise, but technically possible. They can suspend elements, so they can consume, or accumulate, and then yield all of them in like a batch, or many of them in a batch, right? They can also short circuit, so they can turn infinite streams into finite streams, and they could keep state, between executions. But again, I'm not sure it's a wise approach. And they can also enable parallel execution for stream processing, right? This is what they can do for you. So now we go to the part 3, the how. How is it done? So let's try again. Let's try to approach this count out thing again. And it might work like this. Let me go to the code and here with gatherer. So I'm creating the gatherer here in place, or maybe we can go with this gatherer and up. Yeah, okay, let's do it. It's here. So what I'm doing here is I have a like gatherer of sequential, right? And this is my like a supplier for the accumulator. So I'm going to keep it things in a hash set, right? And I have this integrator. Integrate is like the engine of this gatherer. And what I'm doing here is I have these 3 elements. So the state element downstream. And if my state already contains the length of this element, I'm going to add this length to my internal state, right? And I'm going to push the element downstream, and I return true, which means keep processing, right? So let me just run this thing. And as you can see, it produces this output, so just as expected. And once you know what collectors are doing, right, you can decipher this code, or so it's here, but I can say, I have this unique by length gatherer. Sorry, the second task, which should be, let's enable it here. And this is why IntelliJ IDEA is yelling at me, hey, you should use toList. Well, I never liked that meta in the first place, so maybe not. It's hiding that it's unmodifiable, basically. That's why I don't like it for. Anyway, when you look at this piece of code, right, now, just this method, okay, from here to here, is it more obvious or not what this intent of this code? Now you can name this thing here, right? And when you go and create this gatherer, here you have the integrator method, right? So it takes like I said, the state element downstream, and it's the same story. If the state already contains this length, we already processed or seen this length. We just we don't. Then we push the element downstream. So when I run it again, as you can see, it's giving like unique by length and pushing that, right? This is like extra debug. That's why we always see it. Yes. So this is how it works, right? And just to understand this better, let's delve into this integrator concept and other parts. So this is the formal definition, which I don't like. What do they tell about Java? Usually 2 things, or many things. First, Java is dying. Java has been dying for 30 years, and it still refuses to die, right? And the second thing they say is Java is verbose, right? So I don't know why we don't use this verbosity here, because I think this is kind of like better to comprehend, or easier to comprehend, right? Fun fact, for this type stuff, you can use many letters, okay? And I sincerely believe it's easy to comprehend like this. So we have 3 types: the type of the elements coming in, the type of elements coming out, and the type of the state, right? of the internal state. So this is the interface, right? So as you can see, we have some supplier that will supply us or give us the initialized state. We have the integrator that's taking the state in and out elements. We have the combiner should we need to combine two streams, right? And we have also the finisher that's sometimes useful. As you can see, the only required part is the integrator. For everything else, there is a default. Therefore, we have this combination of methods, right? As you can see, it always requires an integrator, and sometimes you can provide initializer, finisher, or combiner if we are talking about non-sequential, meaning the parallel stream gatherers, right? So you can create it like this, or you can go and just the old-fashioned way, like implement gatherer, right? Whatever you prefer. So the integrator is kind of like the engine. It's the mandatory engine of any stream gatherer. It has this current state, next element, and downstream. It consumes the next element, right? Obviously, and it may inspect the or investigate the current state. Right? If you care about this, it can send any number of elements downstream. You're not limited to just max one, like I said, any number, so from 0 to n. And if it returns true, it means give me more. If it returns false, it means I think we've just seen enough, time to shortcut, right? To process this, stop this processing. That's why I have like a greedy, which is like kind of like a hint. It will never short circuit. The combiner, it combines two parallelizable gatherers. Finisher can still operate on a downstream after we're done with processing all elements. I guess that will be easier when we get just to demos in a second. Downstream is basically something you call to push the elements, well, downstream. And there are a few built-in gatherers. Gathers fold, scan, window fixed, and window sliding. And let me go and show you these. So yes, let me run them. And as you may see here, for the folding one and scanning one, I have exactly the same lambda. Right, this is the lambda. It's even nicely highlighted. Right. So what I do here is like I have like 10 elements, right? And I map them to objects because gatherers don't support primitive types, right? You need to operate on objects. And what it's doing here is, see, folding is basically like, yeah, I mean, if you're into like functional programming, it will like fold them for you. So we get the like just one element, right? So this list yields only one element here. If you need this scanning, it's kind of like working like a prefixing thingy. Okay, it like adds you or prefixes to your element. For example, if you lose something like this, like with concatenation, so this string is like what we've seen as the previous element, right? We can also have window fixed and window sliding. Have you ever been to any recruitment process when they were asking you for some SQL mambo jumbo, and it's like these windowing functions? This, I'm sorry. These things are like tricky and unpleasant. Now in Java, they are kind of like easier. So when you have window fixed, basically, and we have like a sequence of elements, we have like a first window of fixed length, so 0, 1, 2, then we have 3, 4, 5, and so on. As you can see, the last element doesn't have any siblings or followers. That's why it's yielded as like the, I don't know, shrunk one or something like this. When we have the sliding, it's just always the same length, is just sliding one by one, right? So these are the some of the build ones, and there's also map concurrent. Yeah, these are the results. Let me show you a few more. I guess we have time. So there is this gatherers demo. So now I'm going to work on different, I'm not going to work on this, count out, but on different elements, I have just words, okay? I have words. This is the sequence of words I have, right? And we're gonna, like, let's say, process them in a few use cases. So First is length fluctuations, right? Of course, like when you have like production stuff, you need to monitor stuff. And I guess this pun would be not too shameless to say that Elastic is giving you stuff to monitor your stuff. But this is more of a concept. Let's say you have a massive fluctuation in requests, yeah, right? You see like certain spike or like the requests going down, and you need to auto scale up and down. The same for CPU consumption and so on. So I'm like just simulating this, and I see it as a fluctuation if two subsequent words differ by just more than one character in length, right? So one character is like expected steady growth or steady decline, right? If it's too sharp, 2 characters or more, I detect it as a fluctuation, right? So this is what we can do now using this window. Where is it? The window sliding, right? So what I'm doing here, what I'm given is a list of 2 elements, right? Because 2 is because of this, right? I declare this, and then I check the length of the first element. See, this is new API in Java since Java 21. And I also get the last one because there are only 2, right? And the length of this absolute value, if it's bigger than 1, I have the fluctuation, okay? And I can just do whatever I please with it, right? I could like send an email, page someone, something like this. What I decided to do is just to go and system out, right? So as you can see, between noon and redder, there are 2 characters. That's why it's a fluctuation. Now, if you see this code, I mean, it doesn't say, apart from here, anything about fluctuation or something like this, but isn't it somewhat easy to understand what it's doing? Okay, we'll get to that. They can be, have you ever been to Ipswich? Or have you ever bought a dead parrot? Yes. So the other thing is we can have palindrome. So palindrome is to get the element, the words or the like strings that read backwards give us the same. For the sake of simplicity, what I'm doing here is I'm just like lowercasing them all, and I say that what I do here, right? I replace all of them, all the white space characters with nothing. So I just remove them. As you could have guessed, instead of this, I could have used map. But what this shows is that having just gather method, we can basically forget about anything else, right? We could just focus on gather and forget about any other method, intermediate methods. So these are now kind of like convenient shortcuts. And then what I do is like go this filter is palindrome. And again, as you can see, I'm selecting this unique by length gatherer. So as you can see, I can go gather, filter, gather, whatever, right? They don't have to follow each other. And what I get here right now is I get this palindrome, but again, because I added this unique palindrome by each length, right? So I have noon, kayak, redder, and so on. What else do I have here? Some people complain that in Java you don't have tuples. Well, I'm not so sure if we don't have them. See, this is how much it takes to declare a tuple in Java. So do we really need external library? Maybe, I don't know. Anyway, I need to combine these words into pairs, right? And I need to push them into this pair. So what I do here, I have like initially my empty array list. So this is maybe this way would be like easier to read. This is my like initializer. And then I have this gatherer here declared inside. So if my state is empty, I add the element. As you can see, I emit nothing. I just go return true. If I have something in my state, right, what I do is this. I push a new pair of the element I saw in the previous run and the current element, and I clean my state. That's why what I will be doing is basically pushing them in these pairs. So as you can see, I have pair of this, pair of that, and so on. It's just I have odd number of elements because the last word was radar, and it didn't have a pair. And I was told that in France there are such agencies that when 13 guests show to your party, you can hire the 14th one. So this is kind of like this, and this is where you can use finisher. See, so I have this is the finisher, right? And when I have my state, I can see, oh, my state is not empty, which means I have an element that doesn't have its partner. Let me call it this way. So what I do, I just push artificial single, right? So this is, as you can see, where you can use a finisher just to do something after all the elements are gone, right? You can still investigate the state and you can push whatever you please. Do I have something else? Yes, I have the concurrent mapping, and let's get to the concurrent mapping. So I hope with this we'll be able to use streams more efficiently, but who's using parallel streams in a critical path in your system? I mean the path that has to be the most efficient path for the use case. Okay, few people, but just a few. Okay, and perhaps the reason is this, that the parallel streams are blocking. Right, and let me show you what I mean by this. Let me go here and let's go oopsies like this. Now I have 100 elements, okay, and I have this method that's emulating, for example, that I need to go to external system and I will get my result after 1 second. Please don't do that in production, okay? It's demo only, okay? Anytime you see thread slip in production code, it's bad code, okay? If you see it in test code, it's mediocre code, okay? So don't do this. However, if I have 100 elements and it takes one second to process every element, and I will run it as a parallel stream, and I'm not running anything else on my computer, how long will it take? I can't hear you. Someone says 9. The answer is it depends. Okay, the answer depends because it depends on the number of the cores you have, right? So stuff and so on and so on. But let's just see if this one will take 9 seconds, as I'm suggested here from the troll row. Yes, it took 9 seconds to generate this. Why 9 seconds? Because I have 12 cores in this machine, 12 logical cores. So if you divide 100 by 12, you get 8 and the remainder of 4. So the last 4 are still taking the 1 second because you can't split them, right? You can't split the threads slipping between the threads, right? Now, if only we had this thing that doesn't block on sleep, on network round trips when you need to call a database, another microsystem, on read something from file system. Is there such a thing in Java? Yes, you're correct. That's these are virtual threads, right? So as you can see, this might take too long. And by the way, are we able to double the performance by doing something like this? Again, not, because they are using the same ForkJoin pool, right? So this is not the way to use them efficiently, right? And now we have this gem in Java 24, and I'm so unhappy that it didn't get a proper advertisement, that I even wrote like a blog post about this, and it's this gatherers map concurrent. And you can read about this if you prefer reading than watching me. How it works is like this. Here we go, map concurrent, and I say I'm happy to have up to 100 virtual threads, basically, or workers, right? And as you can see, I'm using the same tools to double method. And now, how long do you think it will take? Yes. Yes, 1 second plus something. Exactly. I mean, of course, it's like the other system you're calling needs to be able to process like this batch of 100 elements and so on, right? So it doesn't come for free. You have to be mindful. You can't just go and say 100, 200. But as you can see, now we can use many really parallel streams, right? So with this addition, I think there is like nothing preventing us anymore from using streams instead of like for loops and custom thread pools and so on to have nicely written data processing. Right? Yes. I guess we still have, so this is the way, right? And if we go for like 100, we'll get, and with 200 elements, we still have 100. That would take us to like more or less 2 seconds, right? And so on. So I think we still have time for one more thing. I'll try to show it to you. Sorry, I got confused by too many tabs open. Oh gosh. Okay. All right. So sometimes because I was looking for a good demo. I was searching for a good demo, right? And this is like, again, a shameless pun. If you're searching, sometimes Elasticsearch is the answer. So it's like right in my plain sight, right? So I'm going to show you how we could implement one more feature. There's a thing, fun fact about Elasticsearch, you can keep fields in multiple times at the same time. Not for every type, but for more types. So one of the types is called ngram, right? And there's a thing called ngram tokenizer. And it's very useful, especially for languages like German, right? So you need to buy this, sorry, it was like Heckscheibenwaschanlage. Exactly, bless you, thank you. Like one big word, right? If you don't speak German, it's the rear window sprinkler, right, in your car. Yes, and like you never know where people will start typing, so you need to have these chunks, sort of, right? So when they start typing, you see this, right, appearing, for example, in your e-commerce store. Right? So how it works is this, for example, this is the default parameters, or I can show you maybe here. I'm using here this Elastic start local. By the way, this is like a nice project on on GitHub. You can use to run Elasticsearch locally on a machine. Not production grade, but enough to give you a demo or a feel like I'm using right now. So when I'm analyzing this quick Fox, it gives me this, you see, first Q, then QU, then U, and so on. Or when I analyze this ABCDE, it will give me like ABC, then ABCD, right? Because I have 3 and 4, min and max, then it will give me like this sort of like sliding window, BCD, BCDE, and so on. This is good for such like auto-completion, for example, if you need such a feature in your stuff. So let me go for, let me go for a test, okay? This is what I expect, right? So when I go for ABC and 3 and 5, I expect an exception. That shouldn't happen, right? And when I go, I mean, because the difference is too high. And when I have just 3, I should have ABC, BCD, and CDE. For 3 and 4, I should get ABC, ABCD, basically the thing I've just shown you, right? And maybe, I mean, I'm not suggesting you should re-implement Elasticsearch. I mean, it's open source again, after all. But should you like play with Java and understand how it's working, let's try to implement this feature using a gatherer, right? So I have this ngram gatherer. I check, of course, the starting conditions, if they're correct, and so on. And then I have this initializer, so it's going to be an empty string builder, right? And then what happens, I have this integrator, right? And this integrator is the following. I first append a letter, because I assume I get it letter by letter, right? I first append this letter to my state. So when I get A, I get A, okay? That's in my string builder. And then it's shorter than mingram, so I skip here. It's not maxgram, so I skip here, give me more. I get B. And I get C the same way. And then I have this, oops, it's actually equals the mingram, which is 3. So what I push downstream is ABC, okay? And nothing here, I get like continue. So I get another ABCD, so it's pushed here. And because it's also max, it's also, what I do is I delete the first character and I push BCD. And so on and so on, right? So I should be able to run the test, and let's see if the test is working. Yes, all tests are passing, right? So this is it, right? This is actually the whole logic I need to implement such a thing. Right, how it works, and I guess I hope it demonstrates this. Like, you don't have to always push; you have to push any number, because see, when I get D here, I push 2 elements, right? That's why I have more than just for every letter. Sorry, let me go back to slides now. What I'd like to ask you, each and every one of you, is to always provide feedback for at every conference, every talk, every meetup, and so on, right? Because without your feedback, the organizers, the speakers don't know how to improve their stuff, what you prefer to see or what you don't prefer to see. So you should have it in your like mobile apps and everything. If you're watching this on YouTube, I don't know where the camera is, please make sure you do 3 things. Provide this feedback to me, hit the subscribe button, right? Yes. Like it depends on the personal preference, and this is this is my survey. If you want to let me know directly to bypass the conference, or if you're watching this on YouTube, please fill this survey. Okay, I very much appreciate your feedback. And if you fancy to follow me on social media, I'm on Twitter, I'm on Blue Sky, LinkedIn. I'm not on Instagram, sorry. These are the slides from today. If you want to get the slides, they're here. In 3, 2, 1. Thank you very much.